My name is Adil, and I'm one of the co-founders of Split. Thank you so much for coming to this meetup. I want to start by first thanking Twilio, our co-host and our customer, by the way, for hosting this meetup, as well as Akash, the head of experimentation at Uber. The topic of tonight's meetup is experimentation-driven product development, and we're going to spend some time learning from Akash's experience building out an experimentation platform at Uber. I want to start by quickly introducing myself, Split, and why Split is putting together this meetup. So by training, I'm a data scientist. However, by just sheer brutal torture of working at companies like Yahoo, LinkedIn, Relate IQ, I've basically given up on data science, and I have now become a data infrastructure engineer, because without good data infrastructure, you can't do good data science. Now, what Split is an experimentation platform. What is an experimentation platform, you might ask? Now, experimentation platforms is fundamentally the concept that like one of the missions of Split is to be the world's to power the world's product decision making, right? And now product decision making at most companies, especially when they start up, when they get off the ground, is a very much intuition-based product development, right? The founders have a vision, they're executing towards that vision. However, as the company hits a certain scale, that intuition-based product development kind of does not scale with the company, right? Because you get many product managers, you get many engineers, everyone has ideas. Now, which idea wins? In those scenarios, you want to move. The modern way of doing product development is an experimentation-based product development, in which you let your customers decide what works and what does not work. Effectively, it's a world in which every product release, every feature that you're shipping out, instead of launching it to 100% of your customers, you're first launching it to a subset of them. And that gives you other benefits, such as agility, continuous delivery. It gives you safety, because the blast radius of any given problem is reduced. However, in addition to that, it gives you an automatic A/B test, right? Because you've rolled out first to, say, 10% of your customers, you're now able to understand how this new feature is impacting the metrics you should care about as a company, the KPIs of your company, whether they're at the executive level, whether they're at your business unit level, or whether they're at the level of your own small little team. So that's what experimentation product development is, and that's what Split is doing, and that's the purpose of our existence over here. Now, our speaker tonight is Akash Parikh, who is joining us from Uber. We're incredibly delighted to have him. Akash is going to talk about his experience building an experimentation platform at Uber. After that, we're going to have a little talk by Devang from Twilio, talking about their experience similarly with experimentation-driven product development. So thank you very much. I'm going to hand it over to Akash.
Thanks so much, Adil. Thank you for having me, and thanks to Devang for hosting us here at Twilio. Let me apologize, I was sick over the weekend, so my voice is a little bit hoarse, but hopefully we'll do just fine. So as Adil mentioned, I'm going to tell you a little bit about the experimentation platform that we built. Let's see, it's going to come up. Nope. There we go. Excellent. So what I'll do is I'll kind of walk you guys through a little bit of how we've thought about experimentation at Uber, and spend some time really kind of, give me a second, all these little things. There we go. Kind of give you a sense for how we think about experimentation at Uber and what that looks like. So I want to give you a sense for just why we experiment, where we experiment, to give you some context. I'll actually walk you through a couple of experiments that we've done to give you a sense of what are the kinds of features that we test and how that works. And then I'll walk you through a little bit of what our actual infrastructure looks like. I'll give you a technical walkthrough of the platform that we've built, that we're still building, and then just a bit about where we're headed after that. So before we start, I just want to kind of talk about Uber's mission again. So Uber's mission is to provide transportation everywhere for everyone. And when you look at this, there's two things that make this really challenging, particularly for us on the experimentation side. And that's the everywhere part and the everyone. On the everywhere, when you think about it, we're obviously a mobile-first company, almost mobile-only in some sense. And everywhere means that you have to operate on any kind of data network out there. So when we think about experimentation, both what experiments are users in, what experiences they had, we have to be able to think about how to design that for any kind of network environment. When we think about everyone, that means that we have to think about really personalization or how do we target different experiences to different people. As you all have probably experienced, when you go to different cities, the app is a little bit different. There's different options at the bottom. As we bring out Uber to all the different countries, what the experience is for a user is very different. And so our platform helps enable a lot of these things. Just a little background. So in terms of Uber, we've grown really fast. And so at this point, we are on 6 continents in over 600 cities and 75 countries. And so that's an incredible sort of rate of growing. It means that we've also grown users really quickly. We have over 65 million riders and 2 million active drivers. So these two things provide sort of a unique element on experimentation. It represents a lot of scale and a lot of diversity. But we've also grown a lot as a company. So about a year and a half ago, we were around 6,000 people. We're about 15,000 now. And when you build an experimentation platform in-house, one of the things that comes up is your users are internal employees. And as we've grown as a company, we've also had to think about how do we scale our product to meeting the diversity of our needs internally. So let me talk a little bit about why we experiment. And I don't think this would be new for folks here. I think all of you are probably affiliated with experimentation some way. But at one level, Uber's extremely decentralized. So I mentioned that we have over 600 cities. This means that we have people in cities kind of defining what are maybe the communications that are going to go out to riders in that city? What are the experiences that we might enable? And when you're decentralized at a really high level, to be able to move fast and efficiently, you want to have a sort of centralized place where people are agreeing on the metrics or agreeing on how to interpret the action that they took and whether it was good or bad. So our platform really enables us to move quickly, even though we're fairly decentralized. One of the things we really push for is sort of this notion of the scientific method. We have a number, probably 10 plus different apps. We have a lot of different metrics. And at the end of the day, we want to promote a culture internally of thinking about what is your hypothesis and what's the metric you're trying to move before you start running your experiment. The idea is that you could probably move any metric with any change given enough metrics. And so we want to push people into thinking about what is it that you're trying to do with your changes? What is the impact you're trying to have? And state that up front. And then we're also in this world of shared learning. This goes back to our decentralization. Let's say I found something that worked in San Francisco. Well, I want to tell other cities that are like San Francisco what kind of experiments worked in these cities. So how do we distribute knowledge from successful experiments or even experiments that didn't work throughout the company? How do we share that? And so what we've done is created sort of the central place where you can see experiments and understand how they affected users. So a little bit about where we experiment. I already mentioned we're obviously a mobile app. We have, I want to say, 10 plus apps when you think about the rider app, the driver app, the Uber Eats app, the Uber Freight app. We have individual apps in countries like India around fleet management. So we have many apps. And when we design our platform, we had to think about how do we design something that actually can scale or is easy to use by thousands of developers that are putting it into every kind of app. Double that, by the way, with every platform, Android and iOS. And then as I mentioned, this creates this challenge around all the different countries that we're in. The second place that is interesting for us and where we experiment is marketplaces. So traditionally, when a lot of people talk about experimentation or think about experimentation, they're thinking about A/B experimentation. We don't necessarily have all of our experiments run in A/B fashion. We are a two-sided marketplace. It's entirely possible that what you do with one cohort of users affects another cohort of users. So for us being and we're an n-sided marketplace, apps like Uber Eats have actually 3 sides. They have the restaurant, the driver, and the rider, or the sort of eater. we have to think about what are the interaction effects. If you're running an experiment in San Francisco that's, let's say, looking at surge pricing, you can't just run it on half of San Francisco because that half of people is going to affect the demand in the city. That's going to change what surge is for the other half. So this is actually a really unique challenge that we face. And then, again, multiply this by 600 because every city is its own unique marketplace. And what does this mean when you're trying to build a sort of centralized experimentation platform that can handle that? And then we are, on our backend. So we have thousands of microservices. We've moved to sort of a very exclusively microservice architecture. And this means that we do experimentation across all of our services. If you request a ride, you may hit 50 different backends in the process of getting that request fulfilled. Any one of those backends might be running a different experiment or thinking about maybe a new algorithm that they're testing or a new refactor that's going out. So when we think about experimentation, we're playing on all of these surfaces. And that means that building a platform that can support this comes with some unique challenges. So before I jump into sort of what we've built, let me talk a little bit about experimentation. So here's sort of the canonical example. I think this is the AB one that everyone knows. Here you'd have, let's see if this works. No, it doesn't work. But on the left side, you can see it says share. And on the right side, it says free rides. And this is a pretty simple test. It's sort of a copy test. Okay, which one got more click-throughs? If anyone had to guess, which one do you think was more successful? Free rides, right, of course. So this is a very typical kind of experiment if you think about it. And one that we've run through our platform. And of course, as you said, free rides won. But let me walk you through some sort of other examples of experimentation at Uber. So this one is around the notion of cash. So if you imagine sort of maybe the first time you used Uber, one of the magical experiences that you get is you kind of just walk out of the car when the trip is done. There's no figuring out if this driver takes credit or cash. There's no conversation around actual payment. So the app is created this magical experience where it happens in the background. Turns out that isn't always effective in every country. Not every country has great credit card penetration. So how do you sort of start addressing markets where that's not the case? So we looked at this about a year and a half ago, and we started with kind of a product standpoint, if you will, like, oh no, that's introducing cash is really going to change the magical experience of Uber. But then we thought, let's run an experiment. So we did some experiments in India where we looked at what is introducing the option of cash, which is a really common form of transaction in India, due to things like the likelihood of taking a trip. And we saw it immediately had a positive impact. And so when we test ideas like this, we're testing them in markets, we're fundamentally changing what might even be the feel of the product. This isn't a A/B test of India versus some other city. This is saying, what is the right experience for this market to enable the app to work better here? Another example is about a year-ish, a little over a year ago, we rolled out a redesign of the driver app. So we completely overhauled the entire app. Now, when you do an entire overhaul of the app, you're not releasing features in piecemeal. You're sort of saying you either have the new app or you have the old app. And we ran this through our experimentation platform where essentially our experimentation platform was the feature gate of whether you run the new design or the old design. This comes with a lot of interesting challenges. You can't really measure a metric across an app redesign. Fundamentally, we're just measuring different things in the new app. We may have not thought about metrics in the old app that we cared about in the new app. So we were looking at very different things when we were making a change sort of this big. And the last one here I'll talk about is what I mentioned earlier about marketplace. So one of the things that we look at Uber is kind of wait time. And what I mean by wait time is if you're a driver and you've just dropped off somebody, what is that time that you're waiting till you pick up the next passenger? That's idle time. That's time where you're not making money. And when I was mentioning earlier about marketplaces, one idea that we tested is this idea called forward dispatch. And the way it works is, and some of you may have seen this because we've now rolled this out, but when you're on a trip and you're approaching the destination of that first rider, we will actually send you a possible pickup for a second rider before that first trip is even done. This entire experience ran through our system. And this is an example of something that we think of as like a marketplace experiment. In this kind of scenario, if you have drivers that are more utilized, that's going to change the nature of the marketplace. It's going to change the supply-demand interaction. And so you can't run this like an A/B test. You have to run this in a very different way. And that's something that we had to think about and build into our experimentation platform. So with that, I'll sort of jump into the background of the kind of infrastructure that we have. We've broken down how we approach experimentation into 4 different sort of pieces. And I was having a conversation here earlier today, but each of these pieces kind of has almost a different end user. And one of the challenges that you'll face is, for anyone who's thinking about building something internally is, as your company grows, the people coming to your product are extremely diverse. You've got engineers, data scientists, product managers, marketing folks on the CRM team, like all sorts of ops folks. You've got all sorts of different people coming to your tool with different levels of knowledge of experimentation, technical, all sorts of things. So as we break out our experiments, we think of it sort of in 4 pieces. The first is sort of the experiment creation. What is it that you're trying to do? I'll walk through all of these 4 phases in a second, but what is the experiment that you want to run? Let's collect some information about that. The second part of it is evaluation. Once you've set up the experiment, how do we assign users to being in treatment and control? What is the constraints around who gets what experience? And how do we go through that process? The third part of it is around instrumentation, and I call this instrumentation and implementation. From an engineering side, a lot of our experimentation right now is built where developers are actually going and building the feature. So they're building version A and version B, and they're toggling version A versus version B based on what's coming back from our system. So there's a step where the developer has to go in and actually implement the experiment. And then, of course, there's the analytics. There's sort of how do you measure and look at these results afterwards. So if I walk you through a little bit of our the pointer on this doesn't work, so maybe I'll just walk up here. So it starts with our management UI. We have sort of an internal web page, web app that you go to where you can create new experiments. This actually stores all its data in a backend service. It's sort of our metadata service that captures all the information about the experiment. We stash that away in another service around MySQL. And this is a little bit of what it looks like. So you're going to come in and you're going to configure the name of the experiment, the description, what team are you. But you're also going to tell us what app are you working on, what's the surface that you're looking at, what's the hypothesis that you're trying to test, what's the metrics that you're looking at. Give us some documents that other people who are coming and look at this experiment might reflect to say, okay, what is this experiment trying to do? We want to collect all this information, and it goes back to that shared learning I talked about earlier. How do we actually capture the information behind the experiment so that we know how to think about it in the future? Once you sort of create the experiment, you go to what we call implementation. So this is what I was mentioning earlier. You're a developer. You're going to be developing the feature in the mobile app. Maybe you're working on the experiment I mentioned around forward dispatch. You need to both develop the feature and say, okay, well, these are users in control and users in treatment. But you also need to enable all of the instrumentation. So you need to tell us, well, did a user see control? Did a user see treatment? And get that working. So that's the phase around implementation. Of course, to connect these 2 pieces, and this is kind of what that might look like on the developer side. So this is a snippet of what a developer might have to do 2 things. One is test whether or not this user is in cash payments, and there'd be something here around what do you do if they're in cash payments, but also to log out that they are in cash payments so that we can record that treatment event is what we call it, impression event, other folks might call it, down the road. Then to connect this together is what we call evaluation. So this is to say, when I open my app, when I take out my phone and I open the Uber app, what experience am I going to see? And what we have is, we're obviously mobile is the key for us. So our mobile app talks to something that we call the treatment service. And the treatment service is consistently in the background syncing all of the experiments that have been configured, everything that we know about what is supposed to be running out there. And a request will come up from the mobile app and say, hey, what experiments am I in? And we'll evaluate the entire scope of experiments and return back the information saying, here's what experiments you're in, user, based on your location, based on what app you're using, based on what version you might be on, based on all the sort of targeting criteria that you can think of. Plus, well, what's the distribution? Is it 50-50 control treatment split? Is it a 90-10? How have we distributed across the different experiences? This service, and I've put some icons here for people who are interested in kind of what we've used to write these services, but this is one of the things that is extremely high QPS. This is like a very high tier service. You can imagine it gets hit on every app. Every time you open the app, and we talked about 65 million riders, 2 million drivers, all these countries. This service is, has to be highly reliable, has to be always available. Imagine what are the things that might happen when this service is down. If you were in an experiment today and you come back tomorrow and suddenly you're not in it because our service was down. If we've thought we've rolled something out to 90% where we said, hey, we've really enabled this for the majority of people, and suddenly the service is down. This service needs to be sort of what we call tier 0. It needs to be at a level of scale that can support Uber at the trip level. And then we return the response. And this is a little bit of what that setup looks like. So on the left-hand side here, you see we think about what is your targeting constraints. Who are the users that we are looking at to say, these are the users that should be in this experiment. In this case, it says, and for those who can't read it, iOS, riders, and in Houston. City is actually really big for us. We do a lot of different tests in different cities. We might have, you might see some of the things that we've recently rolled out with the driver, where we might test out tipping in a few cities before we go broad with it. And I've mentioned this multiple times, but as being a distributed company, when you're testing out something in a city, you need a lot of coordination. You're coordinating with the ops folks in that city. They're going to get the questions. You're talking to customer service support saying, hey, we're rolling out this new feature in this city. Here's the kind of experiences that might be different. Here's how you need to handle it. So there's a lot involved there. And the right-hand side here captures the sort of second part of evaluation. And this is the distribution or sort of the percentage, right? So of users that meet this set of constraints, take 50% of them and then assign them 50% to treatment and 50% to control. And you can see here that we sort of done some visuals here to help people understand how they're thinking about it. Okay, well, in this waffle plot, I'm not looking at all users, and I'm looking at only a subset of them. From here, the sort of fourth phase of it is on the analytics, and this is where I think Adil was mentioning this, right? Data infrastructure is a hard problem, and when you're dealing with a service and sort of an app that's used at the frequency we actually collect a lot of information. There's a lot of impressions that happen. We're talking about billions of impressions that we have to process. All of that comes through sort of a Kafka pipe. We ingest it into Hadoop. We pull down all of the configuration information because one of the things that we do is we don't actually pass all the data down to the mobile app. We just pass as little as we can. This goes back to the kinds of challenges we have with reliable networks, and we don't want to be sending a 15 megabyte payload down to an app. So we send in as little information as we can. We sort of combine it with server-side information that we might have had to then weave into our actual analytics UI. And unfortunately, I don't have a screenshot of it because we just overhauled it entirely. But this is the sort of flow of how we look at experimentation and what that system that we've built, and this has evolved over the last 2-ish years, has looked like. We've made a lot of changes, and early on, I'll tell you that this whole thing was kind of one monolith, and we started to see that there's really different use cases. You had to support different sort of scale for treatment than you needed for a person coming in and making a change to a UI. And so we started to split our services out like that, and now we're in more of a stable state here. I want to dive a little bit into mobile, because obviously mobile is sort of our bread and butter, and how do we think about this? So on the mobile app, if you remember sort of a few slides back on this real-time endpoint, the mobile app hits this real-time endpoint, and we actually evaluate all experiments at that time. So the idea that we have is when you open your app, we evaluate all experiments that you're eligible for and give you a response back, and that is stored locally on the phone. What this does for us is it allows us to have some sense of reliability and consistency. If you lose network, you can always fall back on the local cache. We can keep you in a consistent experience over time. Similarly, when you are in an experiment, you might log an impression. So we collect those impressions on the mobile app, and we store them until we get enough network to sort of send it back up. And this allows us, this kind of caching and storage on the app allows us to be a little bit more tolerant to network outages. And one of the most important things here is you want to stay consistent. You always want to, once somebody's treated, they're treated, and you want to stay treated. And this kind of caching allows us to do that. Of course, this comes with its own challenges, because there's times where you'll say, I actually want the most dynamic, the freshest value. And so as we've evolved over the time, we've given developers sort of access to themselves sort of saying, do I go to local storage, or do I sort of force the latest value that might have come up? This has a lot of challenges. I won't go into all of it, but at a level of, you're really putting a lot of work on the developer to understand what it is they're trying to do. And the reason that this becomes even more tricky is typically when you're in this phase and you're the developer, your main focus is, I want to get the feature to work. I'm building a feature. I'm building cash payments. My thing is about cash payments. You're not thinking about what is the thing I have to do to make the analysis that's going to happen a week from now valid. Right? So if you put this log impression in the wrong place, a week from now, a data scientist is going to come to you and say, I can't do anything with these results. But you're not thinking about that at this stage. And so one of the things that we focus on, and one of the challenges we have, is around education. How do you sort of take an engineer who might be thinking about building a feature and also get them to think about, well, how is that feature going to be analyzed down the road? And what does that mean? And what do you have to do now to get that correct? I will say we've tried education, we've tried a lot of different techniques, and I think ultimately what we want to do is move to a solution where the product is just simpler, where you're not having to decide against local cache versus more dynamic experiments, and we're toying around with ideas around that now. And then, of course, we queue up the events, and they go back up to our analytics service, and we capture it for processing later. So, kind of with that's kind of a high-level overview of what our technical architecture looks like. I wanted to cover just a couple things, and we can talk about questions and other thoughts. But what are we sort of working on now? What are we going with what we've built, and where do we see the challenges coming for us over the next 12 months? There's a few places. So one, and there's many of them, but I wanted to talk about three. One is more scale. So we are still growing. We are getting more apps, more employees, more users. We need to continue to scale. And one of the things that is definitely scaling is the number of experiments. So you heard me mention that we evaluate all experiments when you come up as a mobile user. How do we scale that? How do we get to a point where if we're running tens of thousands of experiments, that's done efficiently? Scale is something that we see in many different ways. So of course, as we get more users, we're getting more impressions. So we have data infrastructure problems. I mentioned we have 10 plus apps. This means that we have hundreds of metrics that we're computing. So when we think about the analysis that's happening, we're trying to join our impression data against data all over the company. We have hundreds of metrics in our system that's only growing. We're looking at, I think Adil was mentioning this, right? There's your executive level KPIs, there's your business unit KPIs, there's your team level KPIs. We have all of that in here, and that's only growing as we come out with new features, we come out with new products, and as we grow. Second thing that we're looking at, and this is one that we're pretty excited about, is around continuous experimentation. So one of the things that you saw a few slides back was kind of that UI. And one of the things about that UI is you have a human, a person that goes in and kind of controls what is the setup of this experiment. And what we're looking at now is we're seeing experiments or seeing use cases where people might run an algorithm and they might parameterize and say, oh, there's 4 different parameters. We don't know what the optimal values for the parameters are. And what we want to be able to do is say, let us take care of designing the experiment and iterating the experiment for you to find those optimal values. So you don't come in every day and say, oh, let me try treatment 2, which is these 4 values, and then, okay, a week later I'm going to try treatment 3, and it's these 3 values. What we want to do is actually, I mean, you saw sort of our loop. We have the end-to-end loop. We know for the experiment that's running what the metrics that come out look like. And if you just join that last leg there and say, based on the analysis that we understand, here's how we're going to change the experiment, and we're going to look at it again. And we're going to keep running this in a loop where we say, okay, we tried these 4 parameters. Here's what happened to the metrics. Now we're going to do a different set of parameters and keep running that in a loop to find optimal values. So this is actually one that we're really excited about because when we talked about sort of experimentation should enable, and I think Adil mentioned this, you want experimentation at your company to enable speed. It should enable fast decision making, fast iteration, fast movement. How does your experimentation system unlock what you need to do as opposed to sort of hold you back? And this is one of the things that we think is actually a real step function in that kind of change. And the last one that I'll mention here is around regression detection. So I've largely talked about experiments where you're trying to impact some sort of positive change. We have a new feature, or we have a new sort of text. We have new things that we're going out with that we want to have positive impact on our users. Well, at the same time that we are actively running experiments, we're always running this one experiment all the time, which is I'm giving a user new code. And if you think about that as that's always an experiment. I'm always giving you something different than what you had yesterday. And is that good or bad? And what we found is for certain things like, let's say, app crashes, we can actually triangulate regressions in the app experience down to actual features that developers are developing because we have this data where we say, you know, some users are in the feature and some users aren't. And now we can suddenly say, hey, turns out that users who have the treatment are seeing a higher rate of crashes. We are seeing a regression here. We're going to alert the developers, and then they're going to go in and sort of investigate. And this is actually an interesting use case for experimentation. It's not the conventional way that you'd think about it as, oh, I'm trying to test something, what's my hypothesis? In this case, we have a pretty fixed hypothesis. My hypothesis is I'm not regressing the overall metrics. And we're building this into our flow, similar to continuous experimentation, where when it's running, without you having to do anything, we want to notify you that we detected some regressions, and you need to follow up on it. So the last thing I'll mention, and sort of I'll turn it over to Q&A, or actually Devang is going to talk, is kind of what's our team like? What does our team look like? And I've talked to different companies who structure themselves differently. So we actually bring together mobile engineering, backend engineering, data science, and product together as one team that builds out this entire infrastructure. So we have our data scientists that are working both in our production systems as well as doing research. We have our mobile engineers who are working on APIs for the thousands of mobile developers at Uber. We have our backend engineers building all the systems we talked about, data infrastructure, but we sort of approach this problem very holistically, and that's the kind of team it takes to sort of build out the end-to-end. So that was kind of the 10,000-foot walkthrough of what experimentation and what the XP team at Uber has built. A lot of what I just walked you through is what we've built over the last 2 years. And some of that stuff in the future is what we're focused on building out over the next year. Thank you.
Thanks, Akash. So, folks, we're also hiring. I'm with Twilio. I'm Devang, and it seems like it's also a family gathering today. So we're customers of Split, and Uber is a customer of Twilio. I mean, mind blown. So as I said, my name is Devang. I lead the solutions marketing team at Twilio, and just wanted to. I don't have any slides. I just wanted to talk to you about a different frame of experimentation. We heard about Split earlier, and then we heard about approaches to experimentation and methodologies from Akash. So I wanted to see with a quick show of hands as to how many of you already use Twilio. Great. And then how many of you do product development? Great. So a lot of product developers, some who have used Twilio. What I want to do today is just lay a few seeds in your brain about how you can use Twilio for experimentation. Because when it comes to real-time communications, experimentation is sort of in, I want to say, dark ages. Like on mobile, on web, experimentation is a thing that people do. But when it comes to communications, experimentation is the last thing that you would think about. I mean, if you can send a message out, an SMS, it's great, job done, right? But just as you are experimenting with your emails, just as you're experimenting with your web experience or mobile experience, communication experience can also be experimented with. So let's take a few examples. The way most people are using communications within their company are around 4 areas. One is marketing, like I want to send a promotional message out. Another one could be something like a commerce or a sale, like a transaction is taking place. So you would receive a receipt, or you would receive a call saying, hey, I want to buy this thing through a sales contact center. or it's a logistics coordination, which is what Uber uses us for, sending a text message saying, hey, your Uber's outside your door. Or it could be customer service, you calling in saying, hey, I need help. And all of those areas can be built with Twilio's communication APIs, whether it's messaging, whether it's voice, video, wireless, whatever the channel, it can be built with Twilio. The thing is that each of these areas have opportunities to test or experiment. So for example, if you were to send a promotional SMS out saying, here's coupon for 10% discount, or here's coupon for 15% discount, you could test that message even to a specific segment or to a specific content using APIs. Now, of course, we don't have a framework. Twilio is not an experimentation company, but it has communication APIs that make it easier to do that. Another idea would be for sales, you could test out as to where are you receiving your inbound leads from. So if you're running a campaign where you have phone numbers put out on 3 different websites, or based on some key terms, search key terms, you could associate that phone number specifically for that attribution. And then you could test what key term is driving most amount of leads. Another way to test would be in terms of logistics. If you are delivering, let's say, an account notification saying, hey, your bill is overdue, or there's a service outage, you could experiment as to, should I just send an SMS, or should I also send a voice alert, making a phone call and dropping a voice message? Should that be done immediately, if someone doesn't respond? Or should that be done after 15 minutes, or should that be done the next day? I mean, there are many parameters that you can test about that experience. And finally, when it comes to customer service, you could test out messages on your IVR. You could say, if someone calls in and the message that they receive the first time is about our hours, versus the message that they receive is our address, what's more relevant for someone to stick through and make through that IVR experience? So I know it's been a long day. I'm not going to carry on with more experiments, but I just wanted to leave that as an idea, and hopefully we can get out from the cave age of testing with communications. All right, well, thanks all.
Akash, Devang, if you have questions for either Devang or for Akash, please.
Hi, my name is Nick. At Twilio, actually, working on experimentation. And I had 2 questions about Uber's approach to experimentation. The first one is what we've discovered on our end is product managers and engineer managers who make experiments, they're not data scientists. They're not even, they don't have stats degrees. They don't know chi-squared and things like that. So I was wondering, one, how do you present those metrics to the people running those experiments? Like, I'm sure they say they're interested in X, Y, and Z, but they might also be impacting A, B, and C and not being aware of it. So how do you present those metrics in a way that makes it understandable for, non-data scientists, non-mathematicians to understand the data they're receiving?
So I actually don't have a screenshot of it here, but we just sort of did a visual refresh on our analytics front end. What we found is a couple things. So one is you have this class of people who kind of just want to say, tell me what the analysis says. Uber has, I think it's like 300 plus data scientists. We have a very large data science team, and we have a lot of teams that have data scientists.
We have like 10.
So we have a lot of teams that have data scientists on them. And actually what we found is the people that were really coming to our tool were data scientists. And what they want is much more transparency into how did you get that number? What analysis did you use? Wait, I think there's skew. I ran this analysis myself using my own Python package or whatever it might be, and I got a different result. Like what's going on in your system? So we've actually spent a lot of time more focused on that because what we've discovered is data science spends a lot of time computing these things over and over again. And if you can actually say, if a data scientist can say, just go look at this tool, I trust the numbers coming out of this tool, that will free up their time considerably. And then they go spend it on research and other things that they're working on. And so we focused ourselves on getting data scientists to agree with what's coming out of it. And then what we're going to find is other people just trust that. If the data scientists trust it, they're okay with it.
Awesome. My second question, unrelated, is I noticed in your presentation there were kind of a slew of languages. You had some Go in there, you had some Python, Hadoop, I'm assuming there's probably Java or Scala in your world. how do you what is your heuristic to determine what language to use for which subsystem? Like you've decided to use Go for one system versus another.
Yeah. So traditionally, Uber, I joined about a year and a half ago, a little over a year and a half ago. We had a lot of different languages that were being used. And we've tried to start consolidating. Obviously, as you grow as an engineering team, it's useful to have a set of core libraries. We've traditionally used Go for anything new that we're building. We used it for all of our high performance backends to start with, but we've now sort of said, hey, all of the things that we're building, we're going to build in Go, except for on the sort of analytics and data infrastructure, where we use some combination of Scala and Java. Yeah.
Thanks. Awesome talk, by the way.
So can you tell us about your approach to two-sided marketplace experimentation?
I can give you a very high-level sense of it because it's much more of a data science challenge than it is an engineering one. There's a couple different kind of approaches, and actually Jeremy is a data scientist sort of at Uber, so he might be able to, if you have follow-up questions. But one of the things that we've looked at is what we call switchback. So we, instead of doing an A/B test of San Francisco, you would turn all of San Francisco on and then all of San Francisco off, and you'd compare the different time intervals. The challenge with that is you need to run that over a period of time where you can smooth out the fact that one of those intervals was happening during the end of a Giants game, and one of those intervals was Saturday night. So there's a lot of nuance. You can't just go back and forth every 90 minutes because one of those 90 minutes is when the bars close. So we've experimented around with what we call marketplace switchbacks. There's some other ideas that we're looking at around sister cities. So enabling a city as treatment and then sort of thinking about a set of other cities as control and how would that work. Now, all of these things are sort of very complicated and nuanced, and ultimately what you want is you want to create a view of two cohorts where from a metrics perspective they look similar. So it doesn't have to be that the cities don't even have to be in the same country. It's like from a metrics perspective, when we look at utilization or whatever the marketplace metrics we want to look at are, that they seem similar, and then we can use that kind of methodology as well. Yeah, we've sorry. I think the mic.
Sorry, my bad. In the presentation, there was a Hadoop Kafka piece of infrastructure with, by definition, is batch processing, delay, if you like. My question is, is there anything that can come real time at expenses of some either errors or mistake, but mostly to mitigate new launches on the in a way to do safe launches to say this is going to break something or not, and then you wait hours after for the batch processing to give you more meaningful information.
Absolutely. So right now we're on, like you said, we're probably around a 24-hour latency due to all the batch processing. We have specific pipelines that we're trying to run at a lower or a higher frequency, specifically to look at the kinds of metrics that we think are going to be impacted in very short time frames. So something like crash count might be something that gets affected in a very small windows, but something like average wait time for the driver, one of the things I mentioned, isn't something that's going to sort of show up in an hour, right? So we're trying to cater our latency to the kind of thing that you're looking at. Everybody will say they want real time everything all the time, and from a data infrastructure perspective, you'll know that that's just not tenable. So we're shaping how we think about what is a faster metric or a faster, lower latency, what is acceptable at a higher latency. As part of this, one of the things that we learned and one of the changes we made over the last year is we used to pre-compute a lot of the metrics for all experiments. And we found that most people weren't looking at analyses. So we moved to a model where we do it on demand. That means that you wait to see your analysis, So now we're looking at, okay, now that we've moved to the on-demand model, how can we make the analysis happen faster? So.
Yeah, I have a question about your research discipline. You made a reference to being data-informed versus data-driven, and I'm wondering if you can say a little bit more about that, because what I heard was you're not going to be a slave to the data, which in turn means if you come up with a conclusion that you're predisposed to not agree with, that gives you your out.
Yeah.
So I'm wondering how you avoid invoking that as a way out of acknowledging a fact that the research revealed.
You know, when we say data for versus data driven, I think we have enough metrics and enough data sources, and we just collect a lot of data in terms of, you know, what are the sort of impressions that have happened, that you could probably draw different kinds of conclusions that you wanted to. So that's a lot of what we say by data informed is we want people to sort of state what they want to do up front. We want to collect information of like, what is the metric that you're trying to move? And when you know, if you're looking at a 95% confidence interval, we could probably find a metric that was positive for your change. But you can't go back and say, oh yeah, that metric, that's what I was trying to do. And that's part of how we think about it.
My question was how many experiments are run against a single user at a time, and if it's more than one, how do you compensate for maybe some overlap and effects of one on another test?
Yeah, so I don't have exact numbers on, it's multiple users can be in multiple experiments at the same time, and as long as each experiment is randomly distributed, we feel like, and the sample size is large enough that we can counteract those effects, we feel comfortable with those.
One more.
Data scientists to kind of make the final call there.
On average, what percentage of users do you roll out an initial experiment to? You showed 50%, but
Yeah.
I doubt that's what you normally.
Super variable. Like there's no actual answer for that. Like all experiments are sort of different shapes and forms. We certainly don't roll things out immediately, you know, like to 90% right away. One of the things I didn't mention actually is when we talk about mobile, you're actually dealing with, I could actually set something to 90% and only affect a very small percentage of the population because it turns out that no one's downloaded the latest version of the app. So there's all of these other kind of drags in the system. Well, I released it to the Google Play Store, but we only set the Google Play app version to 50%. So now only 50% of, you know, Android users will get the app. But oh, by the way, like, you know, the tail on going from version 1 to version 2 for an Android app might be 4 weeks, you know, it might be very long. So at any point in time, there's all of these other drag points in the system. So we try to focus more on the sample sizes you're getting.
I'm curious why you didn't put the treatment service on the mobile app.
We do sort of client-side evaluation. We combine the ability to target with more than just client-side data. So we don't require that you pass up all of the information of how to evaluate the user in that request. So we might say something like, if this user signed up in the city, they're in the experiment, and that information, we don't have that information on the mobile device. Now what we could do is pass down a lot of information to the mobile device and then do all the evaluation there. What we've opted to do is pass up what we need to know from mobile, so things like your GPS, right? If we want to figure out if people are in a city, your OS version or your app version, et cetera. So that's all mobile. We combine that with, well, what information do we have about this user in terms of what we're targeting against? So are we targeting against sign up city or things like that? And that's what we do at server side.
So I believe you were saying that you have quite a few metrics coming in, and you kind of showed that as an analytic service. So I'd assume that might be outside of what you guys are doing with the experimentation. That might be owned by someone else. But for when an experiment is impacting, you know, whether significantly or marginally, potentially 1,000 metrics, how do you choose what to surface to the end user?
what metrics you're looking at. So as I mentioned, our analysis is sort of on demand, and users will come into our tool and say, okay, for this experiment, show me what these 10 metrics look like. And so we're not computing against everything. We're actually actively having users who come in and tell us, and we combine some of that with, we can ultimately combine that with what were you trying to move when you started the experiment. But there's ways to basically users select what they want to look at.
And that gets calculated on demand, or they set that and then it will be
Calculated
or-
on demand.
Okay.
Calculated on demand. Yeah.
I have a question about the team composition. You mentioned that basically there is mobile and backend, and data scientists they belong to the same team. So is the experimentation platform team is a set aside group of people that are run this way, or are you
No, it's
practically part of the development team and everybody's set up in this
I think this is
fashion?
very common for Ubers. Like we have data scientists, engineers, PMs embedded on teams working together against, let's say the driver app or features, things like that. So it's not necessarily unique, but one of the things is we do have a data science team that's focused on what does experiment data science look like? What does experiment analysis look like? So the things we mentioned around marketplace or some of the continuous experimentation, like these are areas where we couldn't just go build this. There's a lot of research that we have to do up front to figure out what we need to be doing to do it correctly. We need to validate the research, et cetera. And so we have a lot of folks on our team that do that too.
So you mentioned this problem in which maybe experiment gets rolled out, and after a week or so you realize that it wasn't instrumented properly or something wasn't correctly set up, so you don't have enough data or the right data to make a decision. What have you found out that works best to prevent those types of situations? Because it's something that I've encountered quite often, and I'm always looking to learn better ways.
I would say that I don't think we've solved this. We'd like to. I think it's a problem. Some of the things that, and it's not necessarily, it's actually not really our team that has really tried to fix it, because affected teams are the ones that are the most interested in this. So some of the things we've seen is engineers and data scientists will work together to come up with sort of an experiment, sort of RFC, if you will, in advance of building the feature. So not only does the engineer know what they're building from a feature perspective, but they know what they have to provide from we need to do analysis later. Here's what we need to make sure is working. Some of the things that we've been talking about, though, is thinking about how to, I think to a question around like low latency, some of those data points, can we provide them at low latency so that as you're developing, you can see like, oh, I'm seeing a balance between the number of users I have in control and treatment, even when you're just internally testing it, right? Those are the kinds of things we see. We see sample ratio imbalances where you forgot to log it for one group, not the other. So there's kind of a set of things that we think we can fix. But a lot of it right now has just been around better documentation, better communication in the team that's developing it. Definitely a problem though, and like, I think as you mentioned, other teams, other companies have it. We haven't found like a silver bullet.
Hello. Yeah, just a quick one. Does your team provide any means for reducing technical debt?
Exactly do you mean by that? So
at one point when the experiment is over, there's a part of it that is dead code.
Yep.
How does Uber deal with that?
Yeah, so this is actually something that has very recently come up, and we have just started tackling. Our approach right now is that we're starting to detect from our side what are sort of stale experiments. So if we find that something is 100% treatment, and it's like that for 4 weeks, we might start notifying people, say, this seems like we don't need to have this anymore. It's a relatively new process, and sort of similar to what you were asking before. Like, I don't think we figured it out, but it's definitely a question that's come up. And the approach we're taking is we've got a lot of data. We've got a lot of signal that we can provide. We know how often the experiment was changed. We know if users are coming in both treatment and control. We know, when it was added to the code. So we're kind of combining these signals to try and come up with this notion of something that is stale, something that may need cleanup, and then trying to validate that those are indeed true, push that to teams to say, okay, go ahead and clean these things up.
I apologize in advance. This might fall into like a horrible interview question that makes you not want to work at a company. But during the process of building the system and as you evolved over time, what were some of the big major challenges that you came across that you never expected? What kind of hit you out of the blue that made you course correct on building the system and evolving it?
I mean, there's different categories of this. I would say on the non-technical side, I think education's one that being the experimentation team, we sort of build these things saying, oh, this is obvious, people will just like understand how to use this. It's really not the case. I think it's, you have to have an appreciation for doing experimentation correctly and being valid is extremely difficult. And you need to think that people will get it wrong, so what are you doing to help them get it right? Whether it's some of the things we just discussed here, things like that. From a technical perspective, I mean, I think going back to Adil's comment, data infrastructure it's complicated, and we've had a lot of hiccups around how we process our data. We have a huge volume of data that we're working with. We've toggled between, as I mentioned, like pre-computing because we wanted users to get results quickly as a user experience, to saying, you know what, this isn't a good use of our infrastructure. Let's actually just make the user wait 10 minutes to get the results back and be much more efficient with our resources. So those are a couple of points. The other places that have been challenging is just mobile. The mobile SDK is really understanding there's a lot of points in that path between my user saw this and what happened in the whole system that resulted in that. If you're building this right now and you're building this yourself, my biggest feedback would be make sure you're actually investing actively in transparency end-to-end in the system. What decisions got made where? If you have constraints that you're evaluating against, percentages that you're evaluating against, if there's packet loss along the way, there's all of these sort of steps where you want to know, well, this user should have been in treatment, but they were in control. Why? There's just a ton of places where that can go wrong. And so getting that sort of debugging or logging or transparency in place is really important. Similarly, on the flip side, as I mentioned, when it comes to looking at the metrics, we built an analytics tool, and immediately the questions are, well, how did that analysis happen? What was the data that you joined against, et cetera? So.
Another question for you. Do you ever experiment outside of product, like internally with operations or workflows?
On our internal ops? So we're more of the experimentation platform. And in that sense, if somebody was building an internal app that people were using and wanted to experiment in it, they could. They would have to log the data. They would have to sort of come up with the metrics for it. We don't typically see that as a use case. Most people are actually integrating experimentation into their product. So instead of experimenting with their end users, exposing experimentation to their end users. So a classic example, I think someone's mentioning, Devang, you were mentioning that one of our leads on our communications platform spoke here a while ago. Well, communications tools and the communications infrastructure and platforms that we build want to have experimentation built into it. You don't want to have to go over here and set up an experiment and go over here and send out your text messages. So you want to sort of go into the communications tool and say, hey, I want to run an experiment where we're sending out these 5 different kinds of messages, and they'll integrate against our platform to make sure that the experiment is set up correctly through our APIs.
Well, thank you, Akash, again, from all of us, as well as Devang and the rest of the Twilio team. Really appreciate it. Just, as Split, as an experimentation platform company, we care deeply about this topic. Building an experimentation platform for Uber is amazingly hard, for Airbnb is amazingly hard. Now imagine building it for the rest of us, right? I mean, it has its own set of unique challenges. So our goal is to get a conversation going across the community, across the engineering community. In that regard, we're continuously going to be doing meetups as well as other events. If you guys are interested in speaking or hosting or just generally being part of the conversation, do reach out. We'd love to hear from you. Thank you very much again. Appreciate it.